Okay, so we know that friction is caused, right? Friction is a resistance to motion. It's caused when surfaces are in contact with each other. Something that's important to know is that, we can see friction. We can see I guess I'm trying to say the impacts of friction on a large scale. But I want to look at what does this look like on a molecular scale. So this is, you see down here, sort of the macro picture. There are two books, and I can move these books. So I'm pushing the books closer together or further away, and it makes a little noises. You may hear that too. So anyways, as I get closer together, right, I could rub these books together, and that would be friction. And immediately we notice that what happens? The temperature increases. Watch that again. So over here's the temperature. As I bring them together and start to move them across, temperature increases. And you see that temperature, right, as the temperature increases, so does the speed or the motion of these molecules. And this is something we're really going to address a lot when we talk about energy pretty soon. But again, big picture, that is what we mean when we talk about what is temperature. Temperature is how fast molecules are moving. If I were to cool this down, they would move slower, right? But as I rub them together, they move faster as they heat up. So temperature is really a measure of how fast molecules are moving. Really, it's a kind of energy, right? It's kinetic energy of molecules. And as molecules move faster, right, they might, it doesn't really work with a book, but imagine I had, a block of ice. As they start to heat up, the structures are going to change, right? It's going to start to melt. It's going to start to move around a lot more. And eventually, if I kept increasing the temperature, it actually start to heat up, right? It would evaporate. So that doesn't really work for books, but the point I'm trying to make here is that heat is a byproduct of friction. Now, another thing I want to point out is notice how this book is not perfectly, okay, this one is, but at least the blue book is not really perfectly flat. And this is true. On a microscopic level, there are no perfectly flat surfaces. There's going to be, you can get something closer, right? We can polish something. You're going to see that in a second. You can take and rub something and make it smooth. If you've ever seen a rock that's been taken out of a river, it's a lot smoother than a rock that's taken out of just the dirt, right? Because it's been that friction is able to pull actual molecules and particles off, and so it kind of smooths it out. And so you can actually see that if I keep going here, eventually molecules are leaving. They're being rubbed away, so they're getting so much energy actually leaving the surface, and now it's a much smoother surface. And again, I could continue. And eventually they would wear away, right? But it is smoother. If you took something that was rough, and you sat there and you went over and over and over and over, it would start to smooth. And that's used all the time, right? If you're in the kitchen, right, and you're chopping up some vegetables, right, you want a sharp knife to be able to cut well, because a sharp knife is able to cut well, and it's actually a lot safer to cut with a sharp knife because it's less unpredictable. So how do you make a knife? If you have a knife that you've used for a while, how do you sharpen it? Well, one way you can do is use a whetstone, right? It's a whetstone is just they have different what's called grain to them, basically different amount of coarseness or roughness. But anyways, you take your knife and you go, over the whetstone, and every time you do that, you are moving metal particles away, right? So you can imagine this as a knife instead. As I do this, I'm getting a more even sharpness, right? A more even sort of surface. So, anyways, that's one way you can think of and conceptualize what friction is doing. Now, there are many, many applications for this heat, right? I'm going to show you two. I'm going to show you one that's old and one that's not. So I think you'll be able to hear this. I might have to mute my mic and see if that helps. But anyways, so this is this video. And if it doesn't work, I'm going to link a document that has the links to these videos in it. But here's one way this is sort of let's do the old way first, right? The old way you can use friction is you can use friction to start a fire. If you've ever been in Boy Scouts, maybe you've done this before. I find that people actually a lot of times might be a little bit confused by starting a fire with sticks, right? A lot of times people think oh, well, I know whenever you start a fire, you just take two sticks and you rub them together like that. But that's actually not You just rub them back and forth, but that's not actually how it works, right? It's not really close. You can rub sticks together and you will get some amount of friction, but you're never going to get enough friction and therefore enough heat to actually get a working fire. So instead, you have to use some tools here. And I'll probably talk over a little bit of this, and we're going to skip around a little bit as well.
So the object of friction fire lighting is to rub two pieces of wood together and generate friction. So friction being the force that creates heat when we rub our hands together, just like this. So the same principle is employed in lighting a fire. So by rubbing these two pieces of wood, this piece of hazel and this piece of ivy together, we generate friction. That friction breaks down the wood, and then when the wood breaks down into a very fine dust that we call a coal, it will eventually start to smolder. Now the wood we'll use today for the bow drill method will be a drill made from hazel and a hearth made from ivy. We're also going to use...
Okay, sorry, I'm skimming out a little bit. So this is, the first thing you're going to notice is he's not going to do it by hand. Technically, you can do it by hand. It's very, 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 very tough to do. And a lot of times it involves kind of like pushing down and taking your hands like that. The much easier, well, I would say much easier, but the easier way is to create what's called a bow. So you see here, this is the bow. It's just a curved, it's a stick that you tied like a string around, and it's curved a little bit, either naturally, some naturally, and then you can also, if you get a nice springy stick, you can actually make it curve using that string. You can
use any wood that has a little bit of a curve to it. So the first thing we need to do is to create a fireboard or hearth. So I'm taking this.
I'm going to skip ahead just a little bit. Again, he's making the drill, which is an important part.
Friction fire lighting, with the point towards the palm of my hand, and then once it's in position, it'll feel quite comfortable.
Okay.
And it takes a fair bit.
So what he's going to do is he's taking that little stick and then kind of looping the string around
just tight enough that when you pull it into position, it takes a fair bit of effort. And then once it's in position, it'll feel quite comfortable. Another little tip is to hold the string so that you can apply extra tension if it starts to slip. It's quite a useful technique. Now here's the bearing block with a limpet shell to reduce friction. Now if we didn't have a limpet shell, we could mash up some green leaves, put some wax, or even a small slug, anything to just lubricate this bearing block and allow this to spin freely. So luckily we have a limpet shell, which is about the best way to lubricate this end. Now getting into position, this is where it's really important to get your position right to begin with, because if you find your position's wrong, it'll be very uncomfortable and you probably will give up before you actually create a coal. So I'm just going to get started slowly. Now if you notice, my left arm is pulled tightly into my left leg. That gives it extra stability and extra strength, and it means I can hold the bearing block solidly and I can apply downward pressure without wibbling around. I'm just speeding up a little bit. You can probably see a small amount of smoke already. Okay, and that's the point we stop at. Now the reason we stop here is because there's one crucial ingredient missing from this. So we've created the depression, we've shaped the end of the drill, and we've shaped the hearth. But the thing we're missing is a notch. Now without a notch in the side here, all the dust will collect around the outside of the hole, and it'll cool down, and we won't actually light a fire. So I need to cut a notch into the side of the hearth, and the notch should be about 1/8 of the hole.
And just to be clear, what he's done is he's taken wood, right, and it's heated up, and then it's fallen onto this leaf here, and that's made what he's called a coal. So that's where your source of heat is going to be, and he's going to put this into what's called tinder. Tinder is something that just anything that can catch fire very easily, and so then that tinder will catch fire easily, hopefully, and then you start to use that fire to build up and burn larger and larger pieces of wood until eventually you have a solid fire that's not going to go out.
We have a glowing coal. Very carefully place the coal into the tinder bundle. Right, now this is where we just allow it to grow a little bit, just put some oxygen in. It always helps to have the wind coming from behind you, And it helps to keep the oxygen flow running through the tinder bundle. And it also stops the smoke blowing in your face, which is definitely worth considering. And there we have fire by friction.
Pretty cool. Yeah. So if you want to try that, if you can successfully get a fire going, let me know, because that's pretty cool. I was in Boy Scouts, and we talked about that method. We never made a fire that way. We usually just use flint. Or flint was hard. We usually use matches. All right. That's a very old way of showing. It's a very ancient style of using friction. Today we have other methods. One I'll just casually throw out there is that a lot of cars have what's called the regenerative braking system. So basically, when you put on the brakes, there's a lot of friction, a lot of heat gets generated. There are actually some cars now, especially electric cars, that are able to actually use that braking, that energy in that braking, and actually use it to charge a battery, for example. Okay, this is a very modern use of friction. Okay, so they're gonna make dumbbells. They're trying to weld these two pieces of metal together. So you see they're spinning very fast, and of course, when they come in contact, again, it's just exactly what we saw with that demonstration with the books and stuff, that as they start to rub against each other, the temperature is going to increase higher and higher and higher and get hotter and hotter until eventually this metal will actually melt. It'll be hot enough to melt the metal just a little bit. Now, what I think is very impressive, and I'm telling you now so you don't miss it, watch how fast this machine stops spinning. It's absolutely incredible, and it has to stop so quickly so that the weld will hold. But it's amazing. So just watch how fast it stops. And did you miss it? One more time. Just so fast. Incredible. And they do clean it up a little bit, but there you have, again, that was two different pieces of metal that are now welded together. And it's a very clean weld. It's very fast using friction. This is called, obviously, friction welding. Pretty cool. So yeah, those are some ways that you can use. Those are some ways that we can use friction in a modern setting. So friction, again, the main points I want to emphasize here, and this is something that will be it will be our test when we have a test after our break. But this concept of what does it look like? Well, friction is where, as molecules, they start to heat up, move very quickly, and if they move fast enough, they leave the surface. They smooth out, right? So this is why, once again, when we polish something, as we use friction to polish something to make it smoother, to make it more level. Those are all uses of friction. And the big point here is that a byproduct of friction is heat, because again, as we're moving these things together, those molecules are going to start moving faster, and that's what heat is, just fast moving molecules. So as you have those things rubbing together, the molecules are going to heat up, they're going to move faster, and that will be that's why heat is a byproduct of friction.